All right, so you've got a computer scientist interview coming up, huh? Well, get excited because we're diving into RoleCatcher's guides to help you totally ace it.
We're going to unpack those tricky questions, the ones they love to throw at you.
Oh, yeah.
Plus, we'll sprinkle in some career tips for computer scientists just for you.
Nice. So think of this deep dive as like a crash course using RoleCatcher's career guide and interview guide, hitting the highlights from both.
You'll be prepped and ready to impress.
Exactly. And hey, don't forget that RoleCatcher has this awesome AI that can actually help fine-tune your answers for the specific job you're going for.
Yeah, it's like having a personalized interview coach right in your pocket. Kind of cool.
I love that. Okay, let's jump right into it.
Let's do it.
The first question they're probably going to hit you with is something like, what inspired you to pursue a career in computer science?
Yeah, it's a classic.
It seems simple, but it's actually your chance to really show off your passion.
Yeah. You got to go beyond, I like computers. Share a story, something unique, something that captures your journey.
Yes. Like, was there a specific moment, a project maybe, that sparked that fire in you? Did you build a website you were super proud of? Or maybe you got lost in a coding challenge and emerged victorious.
Yeah.
I don't know, share that excitement.
And you know what? This is where RoleCatcher's AI can be super handy.
Oh, how so?
Well, it can analyze your story, right, and then help you tailor it to highlight, the specific skills and experience that the employer is looking for.
Oh, that's smart.
Yeah.
Okay, so next up is a question about staying ahead of the curve because, computer science, it changes so fast.
Oh, tell me about it.
They'll probably ask something like, how do you stay up to date with the latest trends and technologies?
Yeah, for sure.
So this is where you show them you're a lifelong learner, right? You can name drop the resources you use, journals, conferences, online communities, and go beyond just reading. Maybe you contribute to open source projects, experiment with new languages in your free time, or even, just follow industry leaders on social media, all of it.
All those things show initiative.
It does.
And, RoleCatcher's AI can even analyze the job description and suggest relevant resources or activities that you could mention.
Oh, wow. So it really does do a lot of the heavy lifting for you.
Pretty much.
Okay, speaking of standing out, let's talk programming languages.
The bread and butter.
They'll definitely ask you, what programming languages are you proficient in?
For sure.
Now, this is your time to shine, but be honest and list the languages you're truly comfortable with.
Quality over quantity, right?
Exactly. Don't just list every single language you've ever touched.
No.
And to really make your answer sing, give concrete examples of projects where you've actually used each language.
Yeah, because it's not just about knowing the syntax, right? It's about being able to apply it.
Yeah, showing them what you can do.
Exactly. And, you guessed it, RoleCatcher can also help here.
No way. I'm sensing a theme.
It can help you identify which languages are most in demand for the roles you're targeting, so you can tailor your answer accordingly.
Okay, that's awesome. Now, next question. Can you explain a complex technical concept to a non-technical person? This one's all about communication.
Oh, yeah, it's a big one.
Can you break down jargon, make those complex ideas understandable to anyone?
Yeah.
Because that's a seriously valuable skill.
It is. It is.
So practice using analogies, everyday examples, think explaining object-oriented programming, using something like a recipe or a car engine. Get creative.
Get creative for sure. And here's a thought. RoleCatcher can actually analyze company culture and suggest analogies that would resonate with that specific employer.
Oh, interesting.
Yeah, like maybe they're a startup with a more playful vibe, or maybe it's a traditional company that appreciates, straightforward explanations.
That's a good tip. Okay, shifting gears a little bit, let's talk about the big picture. Be ready to walk them through the software development lifecycle.
Yeah, hit all those key steps. Planning, design, development, testing, deployment. Show them you understand how it all comes together.
Yeah, and bonus points if you can highlight a time you navigated this cycle in a real project.
Love that.
Emphasize your role, your contributions, and what you learned.
Always good to have a solid example.
Oh, absolutely. Okay, let's talk about bugs.
Uh-oh.
Nobody likes them.
Nope.
But they happen.
They do.
So be prepared to answer something like, how do you approach debugging a complex software issue?
Like being a detective, right?
Exactly. Explain your process, step by step.
Step by step.
How do you isolate the problem? What tools do you use? Show them you've got that analytical thinking down.
Yeah. Yeah.
And, don't be afraid to share a story of, a really tricky bug you conquered.
Oh, I love those stories.
It shows tenacity and problem-solving skills. And those are gold in this field.
Absolutely. And guess what? RoleCatcher's AI can actually analyze the types of technical challenges that might be common in a specific role.
Oh, really?
So you can tailor your story to be super relevant.
That's a good one. Okay, time for a foundational question about data structures.
All right, bring it on.
Be ready for them to ask you something like, can you explain the difference between a stack and a queue?
Oh, yeah, classic data structures.
It is, and keep it clear and concise, right?
Absolutely.
A stack is like a pile of plates, last in, first out.
Last in, first out.
A queue is like a line at the store, first in, first out.
First in, first out.
But what's really important is explaining why we use each structure.
The why, yes.
Like where are they applied in real-world scenarios? Show them you understand the practical implications.
Absolutely.
Okay, now if you have experience leading projects,
Yes.
get ready to shine when they ask you about your project management experience.
All right, time to shine.
Detail the size of the projects, the timelines, the methodologies you used, and most importantly, the outcomes.
Outcomes are key.
Show them you can deliver.
Definitely.
Now, even if you haven't officially managed a project, highlight any instances where you took initiative, like organized tasks or collaborated effectively.
Leadership skills are always a plus.
Always a plus. Okay, let's dive into another fundamental concept. Object-oriented programming.
Okay, love it.
When they ask you to explain it, keep it simple and clear.
Kept simple.
Imagine you're teaching a friend, maybe someone who's totally new to coding, right? Focus on the building blocks. Classes, objects, and inheritance.
The foundation.
Exactly. Real-world examples are your best friend here.
For sure.
Think of objects like car models, right? They share characteristics. Those are the classes.
Yeah.
But they also have unique features, and those are the objects.
Objects.
Right? And you know what? RoleCatcher can actually provide some valuable insights here, too.
No kidding. What can it do?
It can analyze the company's tech stack and even suggest specific examples of object-oriented programming principles that are actually relevant to their work.
Wow. So tailored, so smart.
Super smart. Okay, moving on to code optimization.
All right, let's optimize.
They might ask you something like, how do you approach optimizing code for performance?
Another classic.
So this is where you name drop those specific techniques you use, things like profiling, refactoring, caching.
You got it.
Show them that you know how to make that code run smoothly and efficiently.
Efficient code is happy code.
And don't forget to quantify your impact.
Okay.
Did your optimization improve speed by a certain percentage? Did it reduce memory usage? Because numbers, they speak volumes.
They do, yeah.
And RoleCatcher's AI, it can actually analyze the company's technology and suggest those specific metrics that are super important to them so you can tailor your answer to what they really care about.
I love how personalized it is.
Me too.
All right.
Okay, I think that's a wrap for this part of the deep dive.
That was a lot of information.
It was a lot. So we're going to take a little break and come back with even more key interview questions and career tips for computer scientists. So stay tuned.
Stay tuned. Okay, so we're back, ready to continue our deep dive into prepping you for that computer scientist interview.
Yeah, we've tackled some big questions, but we've got a few more to cover.
We do. Let's talk about this one. What is the role of a computer scientist? It might seem straightforward, but
It does, yeah.
it actually digs a little deeper.
It does. So how do we approach this one?
Well, think about it. It's your chance to really articulate your understanding of the field and its impact, you know?
Yeah, like it's more than just coding, right?
Way more, yeah. What are the core responsibilities, the contributions? You got to think bigger picture here.
Right, like seeing how computer science fits into, the larger technological landscape.
Exactly. You might even want to touch on the research aspect because computer scientists are really at the forefront of advancing knowledge, conducting studies, developing those algorithms, exploring innovative ways to use tech.
Yeah, it's all about problem solving, right?
Mm.
Like they're using computational thinking to tackle these complex challenges, right?
Absolutely.
Yeah.
Designing and developing software solutions, improving existing systems, pushing boundaries, all of it.
And that impact, computer scientists, they play a vital role in shaping our technological future, right?
Big time. Their work has implications in so many fields. Healthcare, finance, entertainment, communication, you name it. It's about understanding that significance, the importance of the role.
Okay, so here's a question that I think might throw some people off.
Oh, okay, let's hear it.
Is a computer scientist primarily involved in theoretical or practical work?
Oh, interesting.
It's like challenging the misconception that it's all about coding.
Yeah, for sure. It's about understand the balance, the theory, and practice.
So it's not one or the other, it's both.
It's both, yeah. You want to acknowledge that computer science, it encompasses both of those things. You need that strong foundation in principles and theories, but you also got to be able to apply that knowledge to real-world projects.
Yeah, it's like, I don't know, the foundation of a house. You need the theory, the blueprint, but you also need the practical skills to actually build it.
Yeah, I love that analogy.
Thanks.
You can even give examples of how the theoretical and practical work like intertwine.
Yeah, totally.
Research and algorithms informs, efficient software development.
Right?
And then experience in software engineering, well, that enhances the ability to conduct, meaningful research.
It's a dance.
It is.
Okay, let's talk career paths.
Okay, love it.
They might ask, what are the career prospects for a computer scientist?
Ooh, yeah, this is where you got to show them you've done your research.
It is.
Like you understand the job market and the potential, trajectories.
And it's a chance to just let your excitement shine through because, hello, this field is booming with opportunities.
It is. It is. Highlight that high demand, It's a rapidly growing field, excellent job prospects across diverse industries. It's awesome.
And speaking of diverse, you can mention the different types of roles computer scientists can fill.
Oh, so many.
Software developer, data scientist, cybersecurity analyst, research scientist. Oh my goodness. The possibilities.
Endless.
And the potential for advancement too.
Yeah.
Like computer scientists, they can move into those leadership roles, specialize in niche areas,
Yeah.
even pursue entrepreneurial ventures.
Oh, yeah.
It's a field that allows for continuous growth and exploration.
Continuous learning.
And of course, you can touch upon earning potential.
The money, yes.
Computer science is known for those competitive salaries.
Definitely a nice perk. Not that it's all about the money.
Right. Of course not.
But it's nice.
It's a good thing.
Okay, here's a question that I think gets to the heart of how computer science shapes the world. How does a computer scientist contribute to technological advancements?
Oh, that's a good one. It's about thinking beyond the code and seeing that bigger picture, right?
Absolutely. It's about connecting your work to that grand scheme of technological innovation.
So pushing boundaries, right?
Pushing those boundaries, for sure. Computer scientists, they're constantly innovating, right? Inventing new algorithms, designing new systems, exploring emerging fields like AI, quantum computing, all of it.
Like being on the cutting edge of discovery.
Oh, yeah.
And then connecting those advancements to real-world applications.
Yes. Give specific examples, how computer science has contributed to advancements in healthcare, communication, transportation, entertainment. There are so many.
Right. It's about bringing those advancements to life and showing how they actually impact our lives in tangible ways.
And it's a journey that never ends, Always seeking those new ways to solve problems, improve efficiency, enhance our experiences. It's awesome.
A lot.
Okay, let's get into problem-solving mode with this question. What kind of problems does a computer scientist solve?
Oh, yeah. Time to show off those critical thinking skills.
It's your opportunity to really demonstrate your understanding of the wide range of challenges that, computer scientists tackle.
Yeah, we're talking problems of all shapes and sizes.
All shapes and sizes.
From developing those efficient algorithms and optimizing software performance to designing secure systems and analyzing massive data sets, it's a lot.
It is a lot, yeah. To really showcase your understanding, I would provide specific examples of problems that they've tackled in different domains.
Super.
Yeah, for instance, in healthcare, they might develop algorithms to improve medical diagnoses or create systems to manage patient data securely.
Oh, yeah.
Or finance, designing algorithms to detect fraud or develop models to predict market trends.
Right. It's showing those practical applications of your skills and knowledge across all those different fields.
It is. And don't forget to emphasize the creative and innovative nature of problem solving, because it's not just about finding any solution. It's about those elegant, efficient, and effective solutions that push those boundaries.
Those aha moments.
Yes.
The breakthroughs.
Okay, let's shift gears to a question that explores the societal impact of computer science. How does a computer scientist impact society? Ooh, this one takes us beyond the technical and into the social and ethical considerations, right?
It does, yeah. It's about understanding those broader implications of our work, how it shapes the world.
Absolutely. I would start by acknowledging the transformative power of technology.
Okay.
I mean, computer science has revolutionized how we communicate, how we access information, conduct business, experience entertainment. It's changed everything.
It's changed everything. So true. And then you can dive into specific examples of how, they've contributed to positive societal change.
Yes, definitely. Think about technologies that, improve healthcare outcomes, connect people, enable access to education, and facilitate economic growth. There are so many.
It's about showcasing that positive impact.
A positive impact, yeah.
But it's also important to acknowledge the challenges too, right?
Oh, yeah. Computer scientists have a responsibility, right? They got to consider the potential impact of their work on things like privacy, security, bias, and job displacement.
It's about being mindful of those consequences.
Yeah, absolutely. And striving to create tech that benefits, all of humanity.
It's a big responsibility.
It is, it is. Speaking of using technology for good, how about this question? Can a computer scientist work in academia?
Oh, that's interesting. Some people might think computer science is like all about those industry jobs.
Yeah, totally.
But academia plays a crucial role too.
It does, it does. There are so many computer scientists who thrive in universities and research institutions,
Yeah.
They're conducting that groundbreaking research, publishing those scholarly articles, contributing to the advancement of the field. It's amazing.
Yeah, and it's such a rewarding environment. You get to teach courses, mentor students, supervise research projects, collaborate with colleagues, present findings at conferences, so much.
Yeah, it's unique, that blend of teaching, research, intellectual stimulation. It's really cool.
Yeah.
And for those who crave that intellectual freedom, academia offers more autonomy,
Oh, yeah.
Pursue your own research interests, explore new ideas. It's great.
You're surrounded by, brilliant minds from all these different disciplines. Fostering that innovation, cross-disciplinary collaboration, it's really cool.
It's a vibrant environment.
Okay, let's get back to basics for a second.
Back to basics.
With this question. What does a computer scientist do? It seems simple, but it's actually a great chance to articulate your understanding of those, core responsibilities and contributions.
Yeah, paint a vivid picture, right? Showcase your passion for the field and the impact you want to make.
So it's going beyond, just a job description and conveying the essence, right?
Yeah.
Of what it really means.
The essence, yes. I would start by describing a computer scientist as, a problem solver, an innovator.
Okay.
Someone who uses their knowledge of computer science principles, algorithms, programming languages, all of it, to tackle those challenges and develop creative solutions.
And then dive into that diverse range of tasks, right? Designing and developing software, conducting research, analyzing data, improving system performance.
Yeah, showcase the breadth and depth of the profession.
And you can't forget to emphasize the collaborative nature.
The collaboration, yeah.
So they often work in teams, right? With engineers, designers, stakeholders.
It's a team effort,
Totally. And highlight the impact.
The impact, yes.
Computer scientists, they play a vital role in shaping our technological future, Their work has ripple effects across so many fields.
So many.
Okay, so getting to the heart of the matter, let's talk about this question. What is the primary focus of a computer scientist?
Ooh, we're distilling the essence now.
We're getting to the core.
Identifying those fundamental principles and goals, What drives the research and development?
So what would you say lies at the heart of computer science?
I'd say it's about advancing knowledge and understanding, exploring those new ideas, developing those new algorithms, designing those new systems, pushing those boundaries, all of it.
It's about expanding those frontiers.
Expanding the frontiers, yeah.
It's like being an explorer.
Oh, I love that.
Venturing into those uncharted territories of, the digital world.
It is very cool. And let's not forget problem solving,
Yeah, that's a biggie.
They're driven by that desire, right? To solve complex problems, use that computational thinking, apply their knowledge to create those solutions, improve efficiency, enhance functionality, address those real-world challenges.
Yeah, it's about using ingenuity to, make things better.
To make things better, yeah.
Find those solutions that benefit everyone.
Absolutely, and that brings us to the impact on society, right?
Right.
Striving to develop those technologies that improve healthcare outcomes, facilitate communication, enhance our understanding of the world around us.
It's using our skills for good.
For good, yeah.
Okay, getting a little bit more granular here. How about this? What are the tasks of a computer scientist?
Ooh, okay, getting into the nitty-gritty.
We are, yeah, painting a picture of those, diverse and dynamic tasks.
Yeah, for sure. But before we get too specific, it's important to acknowledge that those tasks, they can vary,
Yeah, they can.
Depending on the role, the area of specialization, the work environment.
No one-size-fits-all answer.
Not at all, no. But there are some core tasks that are common to, many computer science roles.
Okay, so what are those core tasks?
All right. Well, designing and developing software, that's a big one.
Okay.
That's creating software applications, websites, systems, meeting those specific requirements. It includes writing code, testing, debugging, all of it.
Bringing those digital creations to life.
Yeah, exactly. And then there's conducting research,
Okay.
exploring those new ideas, developing new algorithms, pushing those boundaries of knowledge.
Right, delving deep into that theoretical side.
The theoretical, yeah. And analyzing data.
Okay.
Using statistical and computational techniques, right? Extract those insights from large data sets, working with data visualization tools, developing those machine learning models, communicating those findings to stakeholders. A lot of stuff.
It's making sense of all that data.
All that data, yeah.
Yeah.
Then there's improving system performance. Identifying those bottlenecks, optimizing code, implementing solutions to enhance the speed, the efficiency, the reliability. Make it run smoothly.
Make it run smoothly.
Yeah, and we can't forget collaborating with others.
Oh, right. Teamwork makes the dream work.
It does. It does. Working in teams,
Right.
with those engineers, designers, stakeholders to design, develop, and implement those software solutions.
It's about communication, being a team player.
It is. It is. And it's important to emphasize that these tasks, they're often, intertwined, interconnected.
Yeah.
Computer scientists, they rarely focus on just one task,
Right.
They use that holistic approach, using all those diverse skills and knowledge to tackle complex challenges.
Okay, so let's get a little personal here.
Okay, getting personal.
What inspired you to pursue a career in computer science?
The personal touch.
Yeah, share your story, Let your passion shine through.
Yeah, connect with the interviewers on a personal level. Show them what drives you.
So how would you capture that journey and really, convey that passion?
Okay, well, I would start by reflecting on those early experiences, the ones that sparked my curiosity about computers and technology.
Yeah, like what?
Like building a website, writing that first program, just being fascinated by how computers work.
Right, those aha moments that ignited the passion.
Exactly. Then I'd talk about the specific aspects of computer science that, really captivated my imagination,
Yeah.
That elegance of algorithms, maybe the power of programming languages, or even the challenge of solving those complex problems, using computational thinking.
It's that intellectual curiosity.
The curiosity, yeah, and the love for that technical side of things.
Yeah, and don't forget to mention any role models or mentors who inspired you too, right?
Oh, yeah, mentors are so important. Maybe a teacher who, encouraged that passion for coding, or a professional who shared insights about the industry.
Yeah, mentors can make such a difference.
They can. Okay, how about this question? How do you stay up to date with the latest trends and technologies in computer science?
Oh, this one is all about showing your commitment to continuous learning. Your ability to adapt.
It's about being a lifelong learner, always eager to stay on top of this field.
So how do you showcase that dedication?
Okay, well, I'd start by emphasizing just how important continuous learning is in computer science.
Okay.
The field is constantly evolving, so it's crucial to stay on top of those new developments, those trends, those technologies,
Yeah, it's laying that foundation, showing them you understand the need to, always expand your knowledge.
Absolutely. Then I'd share my personal learning strategies and resources,
Oh, like what?
specific journals, magazines, online publications that I follow, to stay informed.
Being proactive.
Being proactive, yeah.
Yeah.
And I'd highlight conferences, workshops, meetups I attend to learn from experts, network with peers, and gain insights into those emerging technologies.
Right, conferences are so valuable.
Too valuable, yeah. And online courses or MOOCs,
Oh, yeah, I love those.
Deepen my knowledge in those specific areas, acquire new skills.
Yeah, online learning is awesome.
It is so flexible. And online communities or forums, engaging in discussions, sharing knowledge, learning from others' experiences.
Oh, yeah, online communities are great.
They're great, yeah. And if it's applicable, I'd highlight contributions to open source projects, Demonstrates that commitment to practical application, the collaboration.
Yeah, I like that.
And finally, I would conclude by emphasizing the importance of staying curious and adaptable,
Right, because technology is constantly evolving.
It is. So the best computer scientists are those who are eager to learn new things, embrace new challenges, and adapt to change.
It's all about that growth mindset.
The growth mindset, yeah.
Yeah.
All right, let's get technical
All right, let's do it.
with this question. What programming languages are you proficient in?
Oh, the classic computer science interview question.
It is a classic. It's your chance to showcase your coding expertise, but
Yeah.
be strategic.
Strategic, yes.
Don't just list every language you've ever encountered, okay?
Yeah.
Focus on the ones that are relevant to the job and highlight your proficiency.
Quality over quantity.
Quality over quantity, yeah. So how would you approach this one?
Okay, well, I would start by mentioning the programming languages that are like most in demand, the ones that align with my career goals.
Yeah, makes sense.
For example, if I'm applying for a web development role,
Okay.
I might mention JavaScript, HTML, CSS,
Yeah, perfect example.
showing them you're aware of the trends and your skills align with the market.
Absolutely. And then provide specific examples of projects or tasks where you've used each language.
Ooh, specific examples. Good idea.
For instance, I'm proficient in Python, and I've used it to develop machine learning models for fraud detection. Or I'm comfortable with Java, and I've used it to build enterprise-level applications. Something like that.
Oh, those are great.
Yeah, and I'd highlight any certifications or formal training,
Right.
Adds credibility, shows commitment to that professional development.
Yeah, I like that.
And lastly, I would be prepared to discuss the strengths and weaknesses of different languages.
Oh, okay. That's interesting.
Yeah, it shows a deeper understanding, the nuances of each language, the ability to choose the right tool for the job.
It's a thoughtful approach.
A thoughtful approach, yeah. Okay, how about this one? Can you explain a complex technical concept to a non-technical person?
Oh, this is such a crucial skill.
It is, it is.
Because you often need to explain those technical concepts to colleagues, clients, stakeholders who don't have that technical background.
It's about being that tech translator,
It is, yeah.
bridging that gap,
Yeah,
making complex ideas accessible.
So how do we showcase that skill effectively?
Okay, well, I would start by choosing a concept that I'm really familiar with,
That's all right.
and that I can explain clearly, and make sure it's relevant to the job or aligns with my area of expertise.
It's got to be meaningful to the interviewers.
Meaningful, yeah. Then break it down into smaller, digestible pieces.
Yeah, small bites.
Small bites, yeah. Use plain language, avoid jargon, focus on explaining those core principles in a way that anyone can understand.
Keeping it simple.
Simple, yeah. And use analogies, metaphors, real-world examples,
I love a good analogy.
Me too. Like, if I'm explaining object-oriented programming, I might use the analogy of a car, right? The car's an object, its attributes, the color, model, make, and its methods, like start, stop, accelerate.
Oh, I get it, like properties and behaviors.
Exactly, exactly. And encourage questions, feedback.
Oh, wait, interaction is good.
Interaction is good, yeah. Shows you're attentive, willing to adjust,
Yeah.
Practice beforehand, of course.
Practice makes perfect.
It does, it does. Okay, let's shift gears to, can you walk me through the software development life cycle?
All right, so this one is all about showing you're familiar with, like the systematic approach to software development. Right?
Absolutely. Showcasing your knowledge of those different stages involved, from conception to deployment.
Big picture.
The big picture, yeah. So how would you answer?
Okay, well, I would start by outlining those key stages of the software development life cycle.
Okay.
The SDLC.
The SDLC. Yeah.
Things like requirements gathering, design development, testing, deployment, and maintenance.
Perfect. You're giving a clear overview.
And then I'd elaborate on each stage, provide more detail about the tasks involved.
Yeah, get into the nitty-gritty.
And highlight any specific methodologies or frameworks I'm familiar with, like Agile, Waterfall, Scrum, those kinds of things.
Yeah, show off that knowledge.
And emphasize the iterative nature of it all.
Oh, the iterative nature, yes.
Because software development, it's rarely linear, right?
It's not, no. It often involves going back and forth,
Yeah. As new information emerges, requirements change.
It's a dynamic process.
Okay, so moving on, how about this? How do you approach debugging a complex software issue?
Debugging, the detective work.
It is. It is.
Yeah.
It's about identifying and resolving those errors.
Right.
And it requires a systematic approach.
A systematic and logical approach, for sure. So how would you highlight those debugging skills?
Okay, well, I'd start by outlining my general process,
Okay.
which typically includes understanding the problem, reproducing the issue, isolating the cause, developing a solution, testing the solution, and documenting it all.
Solid foundation for a process.
Right. And then I'd elaborate on each step, explain how I gather information, use debugging tools, test potential solutions.
Show them you've got the methods.
And I would share an example of a challenging debugging experience I faced.
Yeah, good story.
How I overcame it, show them I can think critically.
I love a good comeback story.
Me too, me too.
Uh,
Okay, next question. Can you explain the difference between a stack and a queue?
oh, back to data structures.
Yeah, those building blocks.
They are. Stacks and queues, two common ones used in a lot of applications, you know?
So important.
They are. How would you explain the difference?
Okay, well, I would start with a simple definition for each.
Okay, simple definitions.
A stack is that data structure that follows the last in, first out principle.
LIFO.
LIFO, exactly. It's like a stack of plates.
Mm-mm.
You could only add or remove from the top.
The classic analogy.
It is. It is. A queue, on the other hand, follows the first in, first out principle.
FIFO.
FIFO. Like a line at the grocery store, the first one in line is the first to be served.
Makes sense.
And then I would use those real-world examples to, really illustrate how they're used.
Real-world examples are so helpful.
They are.
What examples would you use?
Okay, for stacks, I might mention the under feature in a text editor or the call stack in a programming language.
Oh, yeah, good ones.
And then for queues, maybe a printer queue or a message queue in a distributed system.
Perfect examples.
Thanks. And I'd highlight those key operations, for stacks, push and pop, and then for queues, on queue and dequeue.
Yeah, the core actions.
And wrap up by mentioning some applications in computer science.
Ooh, like what?
Algorithm design, compiler design, operating system development.
Showing that broader relevance.
Exactly. Okay, so let's say they ask, what experience do you have with software project management?
Project management, a crucial skill, especially for those leadership roles, right?
It is.
Planning, organizing, executing those software projects effectively.
It's about delivering, meeting expectations.
It is. So how would you showcase those skills?
Okay, well, I'd give a concise overview of my experience. The types of projects, team size, methodologies used, all of that.
Setting the stage.
Yeah. And then I'd highlight specific projects where I've demonstrated strong skills,
Yeah, specific examples.
Projects where I successfully managed the scope, budget, timelines, where I've communicated effectively, managed risks.
Those are the details they want.
Right. I'd also mention any certifications or training.
Oh, yeah, certifications are good.
Adds credibility.
Credibility, yes.
And I'd be ready to discuss my project management philosophy,
Oh, interesting.
My approach to managing teams and projects.
Yeah, give them a glimpse into your style, your values.
Exactly. And I'd highlight my strengths as a project manager. Things like my communication skills, ability to motivate teams, attention to detail, risk management,
Yeah, reinforce those qualifications. Show them what you bring to the table.
Okay, time to dive into object-oriented programming.
Oh, OP. Hooray.
They might ask, can you explain the concept of object-oriented programming?
Yeah, it's widely used based on those objects, those data structures,
Right.
containing both data and methods.
It's essential.
It is.
Promotes code reusability, modularity, maintainability. It's a big deal.
It changed how software is designed and developed, So how would you explain it?
Okay, I would start by defining those key concepts.
Okay, what are they?
Objects, classes, inheritance, and polymorphism.
The foundation.
And then I'd use those real-world examples to illustrate.
Always a good idea.
Like, for example, I might use the analogy of a car to explain objects and classes.
Okay, the car.
Yeah, a car is an object. It has attributes like color, model, make, and methods like start, stop, accelerate.
So simple, relatable.
It is. And to explain inheritance, I might say that a sports car class can inherit from the car class.
Oh, yeah, again.
It inherits all the attributes and methods of the car, but it adds its own specifics like top speed and handle corners.
Building upon the existing class.
Exactly. And then to explain polymorphism, I might say that a drive method can be defined for both. But even though the implementation might be different, you can call drive on any object that's a car or sports car.
Makes sense.
And then I would conclude by highlighting the benefits.
The benefits, yeah.
Code reusability, modularity, maintainability.
The good stuff.
Okay, so next question. How do you approach optimizing code for performance?
Performance optimization, very important.
It is. It is because it involves improving speed, efficiency, resource usage, all of that.
Making that code run smoothly.
So how would you highlight your skills in this area?
Okay, well, I would start by outlining my general approach, which typically includes profiling, analyzing results, identifying techniques, implementing them, measuring the results, and documenting it all.
That systematic approach.
Yeah, the data-driven approach.
And then you'd elaborate on each step,
Yeah,
right?
absolutely.
Explain how you use profiling tools, analyze that performance data, choose those optimization techniques, and then discuss specific techniques you're familiar with, like algorithm optimization, code refactoring, caching, Yeah.
The specifics, yeah. And I would emphasize that holistic approach.
Oh, yeah. Tell me more about that.
It's not just about those isolated techniques, right? It's
Mhm.
about understanding how different parts of the code interact, finding the best overall solution for performance.
It's a big picture thing.
It is, it is. It's an ongoing process, Requires a deep understanding and that willingness to continuously improve.
All right. Before we move on to the next questions, let's talk about something that can give you an advantage in your job search.
Okay, what's that?
RoleCatcher's AI.
Oh, yes. RoleCatcher.
This platform uses AI to help job seekers optimize their applications and really prepare for interviews.
It's like your personal career coach.
It is. It is. So, how does it actually work?
Okay, well, it analyzes tons of data, including job descriptions, resumes, interview questions, all of it.
Wow.
Uses that data to identify patterns, trends, insights,
So it's taking out the guesswork.
taking out the guesswork, yeah.
I like that.
So here's how it can help. CV and resume optimization, cover letter and application question assistance, interview preparation, and job matching.
That's a lot. Like it's a secret weapon.
It is. It is. So, for example, it can analyze your CV and suggest improvements based on the specific job you're applying for.
Okay.
Identifies keywords, phrases, skills that'll get noticed,
That's a smart.
and it can help you write those compelling cover letters.
Oh, nice.
Answer those application questions effectively, provide suggestions for structure, content, tone, make it engaging and persuasive.
It's like having an AI writing assistant.
It is. It is. It can even analyze your interview responses and give you feedback on, your delivery, your content, all of it.
Oh, wow. Okay, back to the interview questions. This one's all about those qualifications. What are the qualifications needed to become a computer scientist?
All right. Time to show them you understand the requirements, the educational and professional ones.
Yeah, like those standards and expectations.
Exactly. Now, those specific qualifications, they can vary, right? Depending on the role, the industry, the level of seniority.
Yeah, of course.
But there are some core qualifications that are generally required.
Okay, what are we talking about?
Well, education is key. Most roles require at least a bachelor's degree in computer science or a related field.
What?
Some roles, like in research or academia, might even require a master's or a PhD.
Yeah, that makes sense.
Education gives you that solid foundation, the technical skills.
So it's not just about having the degree. You got to have those skills, too.
Exactly. And problem-solving abilities, those are crucial.
Oh, for sure. For sure.
Computer scientists are problem solvers, right? They need to identify problems, analyze them, and develop those creative and effective solutions.
That's like a way of thinking, right?
It is, it is. And analytical skills are super important, too.
Okay.
You got to be able to analyze data, identify patterns, draw conclusions.
Right, making sense of all that information.
Exactly. And don't forget communication skills.
Oh, communication is key in any field.
It is, it is. Computer scientists, they often work in teams, right? So they need to be able to communicate effectively with colleagues, clients, stakeholders, everyone.
Explain those complex technical concepts.
Exactly. Now, there might be additional qualifications, like certifications, industry experience, knowledge of emerging technologies, but
Right.
those core qualifications, they're a great foundation.
They are.
Right.
They are. Okay, so how about this question? What skills are required to be a computer scientist?
This one digs into those specific abilities and talents, the ones that are essential for success.
It's showing them what you bring to the table.
Exactly. Again, specific skills might vary, but some core skills are essential.
All right, so what are we talking about?
Okay, programming skills, those are a must-have.
Obviously.
Proficiency in one or more programming languages is essential.
It's the language of computer science.
It is. And problem-solving abilities, like we talked about before, super important.
They're problem solvers, yeah.
It's about thinking critically, breaking down those complex problems, developing those effective solutions. It's key.
It's key, yeah.
And analytical skills go hand in hand with that, right?
Yeah.
Analyzing data, identifying patterns, drawing conclusions, all of that.
Right, using that information to your advantage.
Exactly. And logical thinking, because computer science is all about logic and reasoning,
Yeah.
Being able to think logically, follow that step-by-step process, debug code effectively. It's all connected.
All connected, for sure.
Yeah.
And communication, we can't forget about communication.
Communication is key, especially in this field, Being able to talk to both technical and non-technical audiences.
Right, you got to explain those complex things in a way that everyone understands.
Absolutely. Now, there might be additional skills that are beneficial for specific roles, like, experience with particular technologies, knowledge of emerging trends, presentation skills, but
Right, those specifics.
those specifics, yeah. But those core skills are a great place to start.
They are, they are. Okay, so let's get specific. How does a stack work?
Okay, a stack, back to data structures.
This goes beyond just defining it, right?
It does, it does. It's about showing you understand how it actually functions.
So how do you approach this one?
All right, well, I would start by giving a clear definition of a stack, emphasizing that LIFO principle, last in, first out.
Okay, LIFO. I remember that.
Yeah, the last element added is the first one removed.
The foundation.
The foundation, yeah. And then I would use a simple analogy.
Oh, I love a good analogy.
Me too. Like a stack of plates. Classic example, right? You can only add or remove plates from the top.
Oh, yeah, that makes sense.
The last plate you put on is the first one you take off.
Simple but effective.
And then explain those two key operations, push and pop.
What are the actions?
Push adds an element to the top, pop removes the top element, and I'd mentioned that stacks can be implemented using arrays or linked lists.
Oh, yeah, the implementation details.
Right, depending on the application. Then I would give some real-world examples.
Okay, like what?
The function call stack in programming, the underrated feature in text editors, or how stacks are used in evaluating those mathematical expressions.
Oh, yeah, good examples.
And I'd emphasize the efficiency. Pushing and popping elements, those are fast operations, making stacks a valuable data structure for certain things.
They are, they are. Okay, let's talk about recursion.
Recursion, all right.
It could be a little tricky.
It can be, it can be.
They might just ask, what is recursion?
Simple question, but a big concept.
It is, showing you understand that fundamental programming technique.
Yeah, defining a function in terms of itself, it can be very elegant.
Elegant, but mind-bending.
Mind-bending, yes. So how would you explain it?
Okay, well, I'd start with a simple definition. Recursion is a process where a function calls itself within its own definition.
Okay, a simple definition.
Like a snake eating its own tail.
I love that.
But it continues until it reaches a base case, right?
The base case, that's important. It prevents that infinite recursion.
It's the safety net.
It is. It is. To illustrate this, I might use an analogy.
Okay, I like analogies.
Imagine standing between two mirrors. You see an infinite reflection of yourself because each mirror reflects the image in the other mirror.
Oh, yeah, I've done that before.
It's similar to recursion. The function keeps calling itself until that base case is reached, like covering one of the mirrors.
Okay, that makes sense.
Then I'd give some programming examples like calculating factorials, traversing those tree structures, or solving problems like the Tower of Hanoi.
Classic examples.
Classic examples, yeah. And wrap up by discussing the advantages and disadvantages.
Both sides.
Both sides, yeah. Recursion can be elegant and concise, but it can also be less efficient than iterative solutions. And it could lead to those Stack Overflow errors.
Okay, stepping back a bit, what about this question? How can computer science be used to solve world problems?
Oh, I love this question. It's about showcasing your passion for using your skills for good.
It is.
Understanding that transformative power of tech, how it can be harnessed to address those global challenges.
It's about making a difference.
Making a difference, yeah. So how would you approach this one?
Okay, well, I'd start by acknowledging the advancements that computer science has already made,
Okay.
Like how it's revolutionized healthcare, education, communication, transportation, all of those things.
It's setting the stage, showing you understand the impact.
And then I dive into those specific examples,
Yeah.
how computer science can be used to solve real-world problems in different domains.
Yeah, get specific.
For example, in healthcare, developing new medical technologies,
Yeah.
analyzing patient data for better diagnoses, or creating those personalized medicine approaches.
Oh, yeah, great examples.
Or even improving healthcare access in underserved communities through telemedicine, mobile health apps.
Technology can really bridge those gaps.
It can. And then there's education, creating those personalized learning experiences, providing access to education in remote areas, developing those innovative teaching tools. It's amazing.
Education is so important.
It is. And the environment, right. Computer science can be used to monitor and analyze environmental data.
Yeah. And develop sustainable technologies, mitigate the impact of climate change, promote environmental awareness. It's a powerful tool.
It is. And addressing poverty and inequality, too.
Oh, absolutely. Creating those economic opportunities, empowering those marginalized communities, providing access to those essential services.
Using technology to create a more equitable world.
Exactly. And I would emphasize that solving these problems requires collaboration.
Oh, yeah, for sure.
across all those disciplines, computer science, engineering, social sciences, humanities. It takes a village.
It does, it does. And then I'd wrap it up by reiterating my commitment to, using my skills to make that positive impact.
Yeah, leave them with that lasting impression.
And that's it for this deep dive into prepping for your computer scientist interview.
We covered a lot, right?
We did. We talked about the role, the skills, those tricky technical questions, even how RoleCatcher's AI can help you shine.
Don't forget to check out RoleCatcher. It's an invaluable resource.
It is. So as you prepare, think about this. What emerging technology are you most excited about, and how do you see yourself contributing to its development?
That's a great question to reflect on. Good luck with your interview.
Good luck.